Hello, today I will be giving a brief introduction to univariate and bivariate analysis for Industrial Revolution and Research Methodology GT01403. Before we learn more about univariate and bivariate analysis, there are two types of statistical analysis that we should know. First is descriptive statistic, and second is the inferential statistic. Descriptive statistics describe as the nature of an object under study on one, two, or more than two variables that call univariate, bivariate, and multivariate respectively. While inferential statistics drawing inference and conclusions from the findings enable to generalize our sample to the populations from which we obtain our sample. Descriptive statistics are very important because if we simply presented our raw data, it would be hard to visualize what the data was showing, especially if there was a lot of it. Therefore, descriptive statistics enable us to present the data in a more meaningful way, which allows simpler interpretations of the data. For example, if we had the result of 100 pieces of students' coursework, we may be interested in the overall performance of those students. We would also be interested in the distribution or spread of the marks. So descriptive statistics allow us to do this. Here is a quick overview of statistical analysis and its component. What is univariate analysis? Univariate analysis is the simplest form of analyzing data. Uni, the red color, means one. So in other words, your data has only one variable. It doesn't deal with causes or relationships, unlike regressions, and its major purpose is to describe. It takes data, summarize the data, and find pattern in the data. Univariate analysis also explores each variable in the data separately. In the table below, we examine variable univariate data pertaining to income of employed residents. Income would be the variable of interest, and we could determine the pattern associated with the variable. There are many ways to conduct univariate analysis: frequency distributions, measures of central tendency, and dispersions. In the table depicting residents' gender, you see the set. There are many ways to conduct univariate analysis. That is, frequency distributions, measures of the central tendency, and dispersions. Frequency distributions refer to the number of various subcategories of a certain phenomenon occur, from which the percentage and the cumulative percentage of their occurrence can be easily calculated. In the table below depicting residents' gender, you see the percentage of both male and female among the employed residents in a particular area. This will be an example of frequency distribution. Frequency distribution can also be visually displayed as bar chart, histograms, or pie charts as shown in the graph below. This is the bar chart, this is the pie chart, and also the histogram. Measures of central tendency focus on central value for a probability distributions. This is also another way to conduct univariate analysis. Three measures that are the mean, median, and the mode. Here we see a dataset of different residents and their ages. One way to determine this is to find the mean, which is the sum of all ages in the data divided by the number of residents recorded, that is 190 divided by 7, giving an average of age of 27. We can also calculate the median by picking the most central value, which is in this data set is 28. As well as the mode, the number that appear the most or often. You can see ages at 22 appears twice, while all other ages appear only once. Therefore, the mode in this dataset is 22. We can also determine the minimum and maximum age in the dataset. The maximum age is 32 and the minimum age is 22. Apart from that, we can also conduct univariate analysis by using a measures of dispersion, which is spread of values around the central tendency. Three measurements of dispersion are the range, variance, and standard deviation. Now we look for bivariate analysis. Bivariate analysis refers to the nature, direction, and significance of two relationships in the study. As we know, univariate involves only one variable, while bivariate involves two variables at the time that we want to measure. In the table below, depicting the level of education and income of residents, two variables involved, we can observe that the higher degree obtained, the more income earned. Level of education depicting the y-axis and income of residents depicting the x-axis. There are also several statistical techniques to conduct bivariate analysis. One is the correlation coefficients. It refers to the ranges between -1.0 to +1.0, sign of which represent the direction of correlations, whether it is negative or positive relationship. On the left graph depicting a positive perfect correlations, while on the right graph depicting a negative correlations, while 0 depicting no correlation at all. Another statistical technique to conduct bivariate analysis is comparing the nominal variables, that is done by comparing the central tendency, comparing ordinal variables, that attempts to measure how values ordered variables relate to each other, and this analysis begins with a simple cross-tabulations analysis. If we want to compare a ratio of variables, we need to use the basic regressions that used to measure the degree of relationship between two or more ratio variables. So in regression analysis, dependent variable is denoted by y and independent denoted by x. T-test analysis is often used to analyze interval data because t-test will clarify the comparison aspect. For example, we want to compare the gender, male and female. This statistics test whether two subgroups or sample have large enough difference between their mean that the difference exists, which is the data is statistically significant. So it is a quick overview to compare the univariate analysis and the bivariate analysis. Univariate analysis involves a single variable, while bivariate analysis involves two variables, which are the independent and dependent variable. Univariate analysis does not deal with causes or relationships. Unlike bivariate, it deals with causes or relationship. Univariate analysis, the major purpose is to describe frequencies, measure of central tendency, which we calculate the mean, mode and median, and also the dispersions. We calculated the range, variance, and the standard deviation. While bivariate analysis is the major purpose of this is to explain correlation and the directions of the relationship. Again, thank you for listening.